This little video is for working with the Phoenix Controls base upgradable valve with smart actuator. We've gotten some calls about how these guys work and how do you command them to make them do what you want. So we'll go over that real quick. So what we have is a 10-inch valve. It has a shutoff cleat. It is a medium pressure and it has a smart actuator. And we have the smart actuator powered off of 24 volts AC, and we've got it plugged in through a little micro or mini USB plugged into our computer. So we're going to go over how's this guy work. So before we can make this smart actuator and valve do what we want it to do, we need to understand the scaling factor of our unique valve. In our case, we have a 10-inch valve, which in theory has a default scale factor, a medium 10-inch, which would have a scale factor of 125 CFMs per volt. But we have a shutoff valve. It has a shutoff or a low leakage cleat. So our medium pressure shutoff 10-inch would have a scale factor of 106.25 CFM per volt. So to show that calculation, we take our desired CFM, we divide it by the scale factor, and we add 2 volts to get our commanded volts. So if we wanted 850 CFM, we would command it with 10 volts. If we wanted 50 CFM, we would need 2.471 volts, or 500 CFM would be 6.706 volts. So you can see we're going to command the valve to 500 CFM, and to do that, we're going to do that by inputting in the correct voltage here. If we were to measure this in the field, and we would assume a plus or minus 5% accuracy, we could read as low as 475 and as high as 525 at this set point. If we were at 150 CFM, we could read as low as 142 or as high as 157.5. So what we'll do is we'll go over here to our device and we'll put in 150 volts, which is 3.412. Cancel. 3.412. It will override. The valve does its magic and it moves. And we're at commanded flow of 150 CFM. So again, our desired CFM divided by scale factor, add 2 gets our command volts. So we'll try 700 CFM. We would need 8.588 volts. So we'll come over here, cancel that, and we'll put in 8.588, override. We've moved again, and we've got to 700 CFM, and our flow feedback is rounds about 700 CFM. So the main takeaway from making this valve work, if you want to command it by a voltage, is to make sure that you have the unique scale factor for the product, for the valve, size and cleat. In our case, we have a 106.25 CFM per volt. We are calculating out we have the CFM we want, so we know our voltage output must be that voltage. If we were to change the CFM, and again, this is just a spreadsheet, if I'll just change this to 600, 625, 7.882, 7.882. You can hear the valve move. 625, 625. We keyed in the voltage. We've got a command flow. We've got a feedback that's pretty close. So that is the trick or the process for working with the Phoenix Controls Smart Actuator. So the last component to making this work in the field is, we've talked about 24 volts AC power. We've talked about using the service port so you can see the system on your laptop. And there's a software program to be able to interrogate the system. But you've got a command and a ground, so this is where you would send your voltage that we calculated based on CFM divided by scale factor plus 2. And then you would get your feedback as well. So you would be able to, when this valve moves, and I'll move it again. Let me just pick a value here. If I were to pick a value, sorry about that. That's when you send the valve to 0 and it doesn't know where to go. Anytime you send it 0 volts below the 2 volts, you get that nasty clutching noise. But as you can see, the device moves pretty quickly between the 2 set points. And that's how you make it work. If you want to command this valve through analog signals, there's also a 4 to 20 milliamp version. It requires a resistor, but most folks deal with 2 to 10 volts. If you send less than 2 volts to this command, you'll get that nasty clutching noise because it thinks it wants to go closed. And then there's some different options with these as well. So anyway, that wraps up everything. I think we've talked about the scaling factor, which seems to be the one challenge on making this work, is understanding that each valve has its own unique scale factor based on its size and whether or not it's shut off and whether or not it's low pressure. So anyway, that's it. If you got any questions, please reach out. Thanks.